Hi, my name is Melissa Nickel, and this is the final project on dimensional analysis. So I have to record. So I have written out everything that I need and all the math that I've done, and I'm going to step by step go through each part and explain how and why I've done it this way. So the weight we're starting with is 120 pounds. All right, so this paper, it contains everything that I was given. So I have the 3 medications that I need to cure this headache, and I need to find the cheapest option available. That is also the best bang for my buck. So medications I have to choose from: Excedrin, which is acetaminophen. Okay, so total capsules, 200 capsules per bottle. Okay. Then I have in it the capsules 250 milligrams of acetaminophen per 1 capsule. A cost of 1 bottle of this is $15.51, and I did this for all of them because this is very important and is needed, and this is a very quick dimensional analysis setup. This you just have to multiply 200 by 250. So you have 200 capsules, they're 250 milligrams each, you multiply them together, that's 50,000 milligrams per bottle. That is how many milligrams you have total. So then I was given that it is 240 milligrams per 35 pounds in the chemical compound C8H9NO2. So then we move on to Advil, which is ibuprofen. So total capsules we have 300 capsules. There's 200 milligrams of ibuprofen per 1 capsule. The cost is $15. And same thing, 200 times 300, we get 60,000 milligrams per bottle. And this was given, so 113 milligrams per 25 pounds, and the chemical compound is C13H18NO2. So the last one we have is Tylenol, paracetamol. So total capsules, 225. So there's 500 milligrams of paracetamol per 1 capsule. The cost per bottle is the cheapest, and that's $14.97. Then same exact thing, just multiply the milligrams by the capsules, and we have a total of 112,500 milligrams per bottle. Then we have 102 milligrams per 15 pounds, and the compound is the same as acetaminophen because they pretty much do the exact same thing. So it is C8H9NO2. So this is what I was given, and this is what I'm going to use to go through and figure out what is the cheapest option for me, for my headache, per body weight, and then cost per molecule. So we have part 1 I have written out here. I did this once and I forgot to mention something, so I'm doing it again. So I'll walk through this whole thing. So Excedrin is the first one. So fine. Part 1 is doses per bottle. Dose per bottle. So we're going to set up a dimensional analysis for this. 1 dose over 120 pounds. Then we have what was given to us for Excedrin was 240 milligrams per 35 pounds. Have to have them like this so they cross out. And then what I had figured out, 50,000 milligrams over 1 bottle. So yeah, you cross out the pounds, cross out the milligrams, then we have 1 bottle, 1 dose. That is the answer. Okay, let me add. So then this is what you get when you multiply on the top, multiply on the bottom, divide into each other. How I got this answer was, so 1,750,000 divided by 28800. So this is the number I got for that. I'm rounding to 2 sig figs. So what I have to do when I round this and look at this number, I round it to 61. That's what I get for that. 61 doses per bottle for Excedrin. Moving on to Advil. Same thing, same setup. 1 dose over 120 pounds. Then we have, this was given to us, 113 milligrams per 25 pounds. This is what we figured out, how many were in per bottle, 60,000. So sorry, cross out pounds, cross out milligrams. So dose per bottle, again, we get it, perfect. That's clean. So this isn't, so this other one, so that's what you get, multiply top, multiply bottom, so 120, so you do 25 times 60,000 divided into 120 times 113, 1,500,000. Sorry, I'm just making sure I'm putting in the correct numbers. 1, 3, 5, 6. Okay, so this is what I got. When we round to 2 sig figs, yeah, no, this is what we want because the 0 doesn't count. That's exactly what we want. 110 doses per bottle. Okay, this one I already have it. So we have, same thing, 1 dose over 120 pounds, 15 over 102, that's given us, so 15 pounds, milligrams. And then this we did. So pounds cancel out, milligrams cancel out, doses per bottle. This is what I got on the top, bottom. This is the number I got in the calculator. I'm rounding to 2 sig figs. This is a 7. So I believe this is right, is 140 doses per bottle. I hope it's right. Okay, so this is what I've concluded so far. So each answer is in the unit of doses per bottle, which is what I set out to do. And then each answer contains 2 sig figs, which is consistent. So, and we wanted 2 sig figs. So now what we're gonna do is we are going to compare these at this halfway point. So Excedrin. 61 doses per bottle, price is $15.51. Then we move on to Advil. 110 doses per bottle, price is $15. Looks a little better. But then we see Tylenol, and it's clear this is 140 doses per bottle, and the price is $14.97. You can't beat that. So Tylenol is going to cure our headache for the cheapest price. So now this is the bit of the tricky part. Okay. So, just making sure I have all my papers. Okay, I make sure I cover everything. All right, so now we have part 2, price per active ingredient. So now we're figuring out what is the cost per molecule in Tylenol. So the chemical compound for Tylenol is this. So, first thing we're gonna do, we're gonna find the molar mass. So carbon, 12.011 times 8. That's giving you this. Hydrogen, 1.008 times 9. That's giving you this. So on and so forth. So we end up, and I put the exact, I didn't round these off from the periodic table. I put them exactly as they are. So I get this, and I put the little about sign, and this, I'm rounding to 4 sig figs because we're adding, and that's the least amount of sig figs that are being added. I hope I'm doing that right. So I get 151.2 molar mass. So we have the molar mass. So now we need to find cost per molecule. So this is like a 2-step thing right here. So first thing I noticed, I started doing it, and I realized I was doing it wrong because, like in nursing school, you can't, the units have to match. That goes for any math, but just because we're working with medicine, you can't divide milligrams into grams. It doesn't work like that. You have to convert one of them and then continue doing the work. So Tylenol, the easier one in my opinion, was to convert Tylenol from milligrams into grams. So I converted it into grams. Now they line up. Now we can do the math to figure out what we need. So we have 112.5 grams over a placeholder. Then we have 1 mole. 1 mole from here is 151.2 grams. Okay, then this is how I figured this out. I had to look this up again to refresh myself on this. So Avogadro's number. So I'm using this because this is a constant that converts moles into the number of molecules, which is exactly what we need in this instance. So you get this number, so you plug this in, so you do top, bottom, divide into each other, you get this number, and you have to 4 sig figs, and then you add this onto there. So this is the number of molecules we've converted. So now all you have to do, once you have the number of molecules, you then just divide to figure out the cost per molecule. So cost per molecule, so cost per molecule, because we figured out that's the number of molecules, that's the cost. So you put it into the calculator. So I did 14.97 divided by parentheses this 4.481 times 10 to the 23rd, and you end up with this. And then I had to make a note because when you do this, the division is reversing this, so it's negative 23. So that is the cost per molecule. So we have figured out that Tylenol is the drug of our choice for our headache. And the cost per molecule, I mean, it makes sense to me. It's really, really small because there's a ton of molecules in a whole bottle of Tylenol. So that is my conclusion to this, and I hope that I did everything pretty much right, if not all the way right. Thank you.